Okay, I just start recording. So if we can rotate, like, Bliss go first, and then Ethan, and maybe Devi, if you want to try.
Got to introduce myself. So I'm Davey from Irvine, Portola High School. I'm a junior, and I can help teach the math, I guess.
Nice.
Oh yeah. So welcome.
Welcome.
Yeah, we can get started here.
Wait, I have a question. For the first one, okay. Hey guys, welcome back to class 2 of sine and cosine. Here are 2 practice problems from last class. Give you guys some time to do it, and I will come back in, I don't know, 5 minutes. Yeah.
Do I go? Oh. Just after like 1 minute, you guys can, yeah.
Okay, I don't think that was 5 minutes, but if you still didn't finish, pause the video and do whatever you gotta do to finish it, but I'll go over the 2 problems with you guys. So first one, we can see that these are special right triangles. This one you can see it's 30, 60, 90, right? So with 30, 60, 90, last class, you guys probably learned that the side, like this side, we call it A, and then the hypotenuse, we call it 2A, and then this side, we call it a square root of 3. So based on the numbers, we could tell that this side will be 3, and then this side will be 3 square root of 3. So that'll be our final answer. And then for the next one, this is a 45, 45, 90, right? Because here we have 45 degrees. And then for 45, 45, 90, we know that the 2 sides are the same. So this is also 2 root 3. And then we know that if this is A, and this will be A square root 2. So we can do 2 root 3 times square root 2, which would be 2 root 6. And that'll be our answer. Okay. Next slide. Wait, do we go to slide 17?
Yeah.
Okay. I don't know who, but someone's gonna take over right now.
Ethan.
So, wait. So I'll let you guys to do this question for like 1 minute, and you guys can pause the video if you need more time.
Tracy, do they have a calculator?
Yeah, I have.
No, I mean like, do the Nepal kids have calculators?
I think so. Well, they can
Okay.
just like, search online, right? If they don't.
Okay.
Oh, and then starts from slides 20 is some new like stuff we probably need to teach. So
Okay. I'll do these two. Okay, guys. Let's do these two problems. So, if you have a calculator, get your calculator ready. So first, we set up the equation for law of sines. So for law of sines, we know that it looks like, so it'll be sine of 39.4 over 7 equals sine of 46.5 over x, right? So that'll be our equation to solve for x using law of sines. And then just to solve that, we just do what we normally do. So we will get x equals 7 times sine of 46.5 over sine 39.4, right? So, and then you can just use your calculator to do it. So 7 sine 46.5 over sine 39.4. X will be about 8. Yeah. Okay. Next one then. So here, I don't know. I assume they're looking for E. So to set up the equation, it will be sine 54 over 7 equals sine 67 over E, and E equal to 7 sine 67 over sine 54. And then take our calculator. 7 sine 67 over sine 54, which will be about 8 again. Right, so actually for both of these, I got like 7.99 and 7.964, something like that. So I just rounded them to 8. It should work. Okay, yeah. Next slide. Okay, let's give you guys some time to do this, and then we'll go over it again.
Liz, if you like refresh your page, I think you should see more slides. So.
Okay, so for law of cosines, Ifan, can you do it, or do you want me to do it?
Okay, I think I know how to do the first one.
Okay.
Okay, yeah. So for this one, we'll use the equation that's for law of sine. And in this case, since this part is A and this part is B and this part is C. So we'll use the formula that's for A, which is A squared equal to is b squared plus c squared minus 2bc times cosine A, and which we'll just plug the number in, and b squared is 16 squared, and plus c squared, which is 20, minus 2 times bc, and 16, oh my god, times 20, and times cosine A. And since this one is a square, and you just square root everything, so and the final answer is 32.907. Yes.
Okay. And for next one, Debbie, do you wanna go?
Sure. Let me pull up the slide. Actually, could you go first? Because I didn't find the slide. Just give me some time.
Yeah, I'll go over this problem.
Okay, thank you.
Yeah. So for the second one, wait, that's the wrong slide. Oh, wait, where's the button? Oh no. Okay, here. Sorry. So for the second one, you see that we have all three side lengths. So we're looking for this one. So our equation will be 16 squared equals 22 squared plus 8 squared plus 2 times 22 times 8 times cosine x, right? So this is our equation. And then we can start putting numbers. So this will be 256 equals 8 squared, 548 plus 2 times 22 times 8, which is 352 times cosine x. And then you subtract the 548, so it'll be 256 minus 548, which will be negative 292 over 352 equals cosine x. And this is an inverse function. So when you're using your calculator, you have to click the, I don't know if you guys have this, but click the second button and then do the inverse of cosine and then put in your number, which is negative 292 over 352. What? This is a huge number. Wait, I don't think I did this right. 146. Probably. I'm not sure. Do you guys have the answer key for this or no?
No, I think you did right.
Okay. Yeah. If I did not mess up my calculations. Oh, wait, yeah. Yeah, I think that's it. Okay. The next page.
Just skip this. This one is, I don't know who put this, but just, yeah.
Do we have to do this one?
Yeah. I just put that up. So,
Oh, this one? Wait,
Mhm.
this one?
Yeah, I didn't go back one. Oh, never mind. Just that one.
This one, right? Okay.
Yeah.
Yeah. So I'll give you guys like 2 minutes to do this because it's pretty easy.
Okay, so let's go over it. If you are not finished yet, please like pause the video and finish your answer. So for those problems, we usually draw on a like thing on that. And then so here is like 0 degrees, 90 degrees, and 180. And then 270. And then when you come back here, it should be like 330. So the first question is that you draw the angle of 210. So we know that right now here is 180. And then also if you like calculate that, so from 180 to 270, here is a 90. And then if you split that to like 1/3, and then kind of right here. So the thing that's is this one is 210 degrees. And then for the next one, it's okay. And for the next one, is that you to draw 45 degrees. So it also, so right here should be negative 45. So also we have a graph like this. So for negative 45, so we know like go this way, if you go this way it's positive, but if you go to the opposite, so it will be negative. So you start from 0 degrees right here, and then you go 45 degrees. So we know right here is negative 90, and then if you split that like somewhere right here, split, so yeah, it should be negative 45. Yeah. And I hope you guys finish last two also. Maybe Debbie, can you try?
Sure. So for the third one, draw the angle for 225 degrees. All right. So we have to first locate which quadrant it is. So it's in the third quadrant, and we know here is 180. Third quadrant is between 180 and 270, I think. Is that right? Okay. So you use 225 minus 180, you'll get 45 degrees, and you just draw a 45 degrees angle here. Yeah. So here is 225. And then for the last one, negative 60 degree is in the fourth quadrant, and you just rotate 60 degree here. Oh, it's negative 60. All right.
Yeah, cool. Well, like, yeah, this one was pretty easy. So maybe we can moving on to the next slide. Okay, so here has some new knowledge, but I believe for you guys it's pretty easy. So rewrite. So first problem is okay. So I'm gonna like go over number 1 and number 2, and for 3 and 4, you guys can like do it by yourself. Well, like Liz and Ethan, do you guys want to go where you want?
I can go. Wait, like right now?
Yeah, because those
Okay.
are new things.
Okay, so when you write 30 degrees in radians, so what we mean by radians is that we have pi. That's what we call a radian. And you can think of pi as 180 degrees, right? So if you see pi over 2, you can think of that as 180 over 2, which you will know will be 90 degrees, right? So just think of pi as 180, because if you look on this graph, this, like this half will be a radian, and then over here is 180, right? So, right, so that's how you know what a radian is. And then over here, if you want to write 30 degrees in radians, since these are small numbers, the easy way to do it is to think like 180 over what equals 30. Well, I think you guys are know 180 over 6 equals 30 degrees, which is also pi over 6 over here, right? And then if you look at this one, we rewrite -5 pi over 3. And as I said, you can just think of pi as 180. So you can put it as -5 times 180 over 3. And then we can cross out these two and make this 60. So you will get -300 degrees. These might seem hard or like weird right now, but as you do it more, you just memorize them easily. Okay, so we will leave 3 and 4 to you guys, and I will come back in 2-3 minutes. Okay, Ifan, do you want to go over 3 and 4?
For number 4, for number 3, so we're use this formula, which is also the formula right here. And for degrees is 45. Ooh. Yeah. 45 degrees. Okay, so the way I do it is divide by 180, which is also equal pi. And 180, I think it's 4, right? Yeah, it's 4. So it will be pi over 4 for this one. And for number 4 is pi over 6, which is same as the first one, not the number 1. So it's 30 degree. But I will put the word besides it. So pi over Oh, okay. Pi over 6 right here, and times pi 180 over pi. And you cross out the pi, and 180 divided by 6 is 30. And that's how you get 30 degree for pi over 6.
Okay, so here is some like more new information, but if you like know and sure about like previous knowledge, this one is also pretty easy. So I will like go over the first one with you guys, and you guys can try the second one. So we know that a clock, it has like 12 numbers. So, and then it asks us rotate from 6 to 7. And then, so that means like 1, right? So if you have a clock, yeah, this clock is so. Okay. And then you have 7 right here. So, you know, like you rotate 6 to 7 is just like 1 spots. So you do 1 over 12. And then you also notice that a clock have like 360 degrees. So you times 330 because it asks you find a degree and radian measure also. So you times this. And then after you time this, you should got 30 degrees. But not done yet. Because you rotate like the opposite side, you know, like you rotate from this way. So it should be negative 30. And then for your radian measure, since you know negative 30 degrees already, so it should be pi negative 5 over 6. So find that like on your unit circle. So you should be good. And you can try number 2 by yourself, and then we're gonna check answer after you're done. Okay, so Ifan, do you wanna go? Or
I can do it. I know how to do this, I think. Okay, so it's still the same clock. And from 5 to 8. So 6 is right here. 9 is right here. So 5 to 8. Something like this. Yes. So 5 to 6, 6 to 7, 7 to 8, which is 3. 3 over 12. And you times 360 degree. Ooh. Equal 90 degree, right?
negative,
Negative.
because you rotate opposite that way.
Okay. Negative.
Yeah, because we usually measure the degree like from here to here, but right now it's opposite, you know. So it's negative.
Oh, okay. So it's negative 90 degree. And negative 90 degree is you put 90 degrees and you times 180 pi over 180, which yeah, you can tell that is negative pi over 2, and that's the radian mode for this equation, this question. And negative 90 is the degree for this question.
Okay, so have we talked about coterminal angles before?
No, not.
Okay.
But yeah.
So what is a coterminal angle? So let's say we have a coordinate plane right here, and then let's say that, let's say this is 45 degrees, right? So you see how here's the line. Oh, so this is 45 degrees, right? A coterminal angle will be using the same line over here and then going this way, ending up with the same x-axis. So this will be negative 315 degrees. So negative 315 degrees is the coterminal angle of 45 degrees. So an easy way to find this is when you have an angle like 45 degrees, either plus or minus 360 degrees from it. And that's how you find the coterminal angle, right? So if you minus 360 degrees from 45, as I said, you get this number. And if you add it on, you will get 405 degrees, which when you go around will be like 360 and then 45, and you'll end up in the same place. So coterminal angle is basically whatever angle that's using the same side of the angle given. Yeah, and there is like infinitely amount of coterminal angles because you can just put, say like the degrees is n, right? N degrees. Or actually, no, that's not a good one. Oops. Say like x degrees plus or minus 360 degrees n. And that n means that you can put whatever number, like you can multiply by 2 360 or 3 360, it does not matter. So there's infinite amount of coterminal angles for one single angle. So I'll do 2 and 4 with you guys, or 1 and 3. I'll just do 2 and 4 with you guys. So let's find one positive and one negative angle that has coterminal, that coterminal with 150 degrees. So to look at from a graph, 150 is like somewhere around here, right? So the coterminal angle is either going this way to get here, or it goes another circle to get here. So you can do 150 minus 360, which is it 210? Yeah, I think it's 210, right? Yeah.
Yeah.
Oh, negative 210.
Mhm.
So that will be one of your coterminal angles. And then the other one, you can do 150 plus 360, which you will get 510. Yeah. So this will be your negative one. And then this will be your positive one. Right? So negative 210. Oh my God. 210. And then 510. And then for number 4, first you want to convert this to degrees mode. So that would be 30 degrees, right? Because 180 over 6 equals 30 degrees, right? So you can do 180 minus 360, which is negative 180 degrees, and then 180 plus 360, which is 540 degrees. So that will be the 2 answers here. Okay, and then you guys can do 1 and 3 by yourself. We'll come back in a minute or 2.
So we left 1 straight, right now. Okay, and then Debbie, you can't like go over 1 straight after third then.
So let me go over the answer. For the first one, 210 degrees. Wait, okay. You just subtract by 360, you will get a negative coterminal angle. And the answer will be negative 150. And for the positive coterminal angle, you use 210, add 360, you'll get 570, I think. Yeah, 570. So for the third one, 7 pi over 3. Wait, why is it? Wait, let me fix this really quick. Okay, 7 pi over 3, you add 2 pi, and you will need to get the common denominators, which you times 3 up and down, you will get 6 pi over, wait.
Yeah, 6 pi
Yeah,
over
6 pi over
3.
3. Okay, here you go. 6 pi over 3 add 7 pi over 3, you'll get 17 pi over 3. And for the negative one, you subtract 6 pi over 3 from 7 pi over 3, and you'll get 1 pi over 3, and you need to subtract it again because you need a negative coterminal angles. So 7 pi over 3 subtract 6 pi over 3 2 times, you will get negative 5 over 3, negative 5 pi over 3. Okay, here you go.
Cool. Yeah. Okay, so right now we're going to moving on to find 6 trig functions. So like it should be pretty easy, but use your SOHCAHTOA formula from the previous lesson. If you have like that notes out, that should be easier. So I'm going to do like number 1 and 3 with you guys. And then you guys can try number 2 and 4 by yourself. So it says find 6 trig functions of coordinate 8 and 8 comma negative 15. So first of all, you draw this thing, and then okay, so your x coordinate is 8, positive 8. So like you count like 1, 2, 3, 4, 5, 6, 7, 8. And then your point should be right here. But the y-axis is negative 15. So I'm not going to draw out, but it's kind of right here. And then you connect, like the point should be right here. And then you connect the lines. So right now it shows you a triangle. And then your 90 degrees thing should be right here. And then you know this side is 8 and this side is negative 15. Okay, and then what you're going to do next is find out the number of the third side, your hypotenuse. So you're going to use the formula that we teach you before. A squared plus B squared equal to C squared. And then after you solve that, C should be equal to 17. Right here. Okay, and then what this means for like 6 trig is you need to solve for sine, cosine, tangent, cosecant, cotangent, and what is next? I left one, right? Oh, sine, cosine, tangent, cosecant, secant, and cotangent. So those three, you need to find out that. But right now I'm going to just do sine, cosine, and tangent, since the secant, cosecant, and cotangent, you just like reciprocal them and then like reflect them, and then you should be okay. So for sine right here, sine data, sine is negative 15 over 17, since is opposite over hypotenuse. Cosine data is 8 over 17 is adjacent over hypotenuse. Okay, so for the angle, you always like do it right here. So here is your like data angle. If you have a triangle somewhere right here, you should be finding this one. So it's always the angle that like in the x coordinate and y coordinate. So right here. And then your tangent data should be negative 15 over 8 is opposite over adjacent. And then, yeah, and then your cosecant. Oh, and then your cotangent should be 8 over negative 15. And then same as sine and cosine. So you just like reciprocal of them. Okay, so I think we should be, well, it's time right now. So maybe you can try like 3 and the rest of the question next time. Or do you guys want to like continue today? Fine. Okay, so next time. Okay, I know we're busy. So, okay, so that's it for today's lesson. So make sure you review the things after the class. So, yeah.